All right, so yesterday we learned about what a function is, right? And I asked you in 3 different ways, what is a function? Or if you can tell what a function is. I gave you some ordered pairs, like 4, 8, 2, 7, 3, 9, 6, 9, right? I gave you those and I said, hey, is this a function? And told you that you can tell whether it's a function or not by looking at the x values. I said, remember why it didn't make sense if you had a kid that turned 12 the same time or whatever? Kirsten, if you need to move, you can. Yeah. Somebody want to switch with her so she can see her glasses are not working right now. So anybody in the front row? Okay. Go ahead, Alex. Thank you. So if you were looking at this, you saw a 4, a 2, a 3, and a 6. You didn't see any repeating x values, so you told me yesterday, yep, that's a function, right? I hope. Okay. That was from ordered pairs. If I gave you a table, so for example, x is 3, 5, 5, and 1, and y was 2, 6, 4, and 9, is this a function? No, because you cannot have any repeating x values. And you said this isn't a function because there's two 5s, right? So that was pretty easy. And then I even gave you a bunch of graphs and said, hey, are these functions? And we talked about something called the vertical line test, right? So the vertical line test says if I were to draw a line like this, and on the graph of the line, my vertical line's only touched one place, then it's a function. So yeah, that's a function. When I go and I draw this vertical line test, it touches here and here, which means the name of this point is 2, -2, and the name of this point is 2, +2. I have 2 x values that are the same. That's not a function. Is that how you interpreted that assignment yesterday? Okay, so this is a function. Okay, this is not. This one was debatable. Okay, so if it had arrows, so we'll skip that one for right now. This one is not, because it's a vertical line. All of the points are on the same one, so that's not. This one is a function. This one's not. And this one is a function. So that was pretty easy, right? Okay, so determining function is not the difficult part, okay? And then I gave you a worksheet that had something called domain and range on it. Yep, okay? And we didn't talk about domain and range yesterday. We're going to talk about it today. So this is kind of where the new part picks up. So that was just a quick review of yesterday. Domain and range. And domain and range are actually really, really easy. Domain is a fancy way of saying, because in algebra, we have to give things fancy names. Domain is a fancy way of saying the x values. So instead of me saying, hey guys, the x values can't repeat, I will say, because Unit 3 is called functions, your domain can have no repeating values. So when I say the word domain, you have to say, make a mental note, oh, she's talking about all the x's. Which would mean then that the range refers to all of the y values. So the domain is the x, the range is your y. If you need to keep that straight, just think alphabetical order. X comes before Y, D comes before R. DX, domain. Okay? So now, if I go back up to these 2 problems here, these ordered pairs and this table, and say, okay, there's 3 parts to every problem you're going to do in 3-2. You're going to tell me whether it's a function or not, then you're going to list the domain and the range. So this answer is yes, list your domain. And usually when you list your domain, you keep it as in order. So 2, 3, 4, 6. 2, 3, 4, 6. Sometimes you'll see it written with these little brackets. Brackets just represent a set of numbers. So the set of numbers for this function has a domain of 2, 3, 4, and 6. The set of numbers for this function that represents the range is the 8, 2, 9, and 9. If you have a repeat, do you have to list it twice? No. So this is going to be 8. Let's do 7 first. 7, 8, and 9. You don't have to list it twice. Okay? So looking at this, We already said no, it's not a function. List the domain, list the range. Go ahead. So you don't have to do repeats. Okay, easy enough? Yeah.
Is there a reason why you put them in like small?
No, not really. It's just kind of like when you put in standard form, you like it in alphabetical order, constants at the last, yeah. All right, so here's the deal. Yesterday I talked about ordered pairs. I talked about a table. And what was the third thing I talked about, remember? I said I need you to answer these 3 questions. 1, is it a function? 2, what's the domain? 3, what's the range? 1, is it a function? 2, what's the domain? 3, what's the range? From ordered pairs, from a table, what's the last one? Graph. And graph is the most complicated one of all of them. Okay? Anything might be complicated compared to this because it's pretty simple, right? You're literally just looking at the x's and looking at the y's and telling me what they are. So let's kind of transfer over to this here. All right. So as I'm looking at these graphs, if I were to say, on this graph right here, what are all the possible x values that could be listed? Meaning, what are all the numbers that could go right there? That's what I'm asking you. And it's a little more in depth. So let's take a look at what that would mean. What direction does the x-axis go? Horizontal. It goes from left to right, correct? The y values go from top to bottom, vertical, up and down, all right? So as I'm asking you to look at the graphs that I'm about to give you, I want you to think about the domain, make 2 little columns, and the range. And I want you to say to yourself, if the domain is my horizontal line, I am concerned with how far left or right does that graph go. Does that make sense? How far to the left does that graph go? How far to the right? Because that's the domain. Which would make then your range would be concerned with what? How far what? Not left, right, but yeah. How far up or down does that graph go? So keeping that in mind, I'm going to tell you that there are 4 kinds of graphs that we're going to see. All right? Graphs. Today. Let's see if we can take a look at these graphs and see if you can figure it out. So on the sheet that I gave you, we're going to list the 4 of them. And I want you to be able to identify them. Okay. So let's take a look at number 1. Do you see any arrows anywhere at number 1? No. Do you see any arrows here? No. Do you see any arrows here? No. So the first type of graph we're going to talk about is the graph that has no arrows.
Is that like a fancy name or it's just called no arrows?
It's just called no arrows, yep. Okay? All right, that's the first graph. The second graph that we're going to talk about is going to be like number 3. How many arrows do you see? 1, 1, 1. 1 arrow. Okay? Leave a line in between here or a little bit of space after. So number 2 is going to have 1 arrow on it. What do you think the next one is? 2. So it could have no arrows, it could have 1 arrow, or it could have 2 arrows. And then the last one is going to be a little different. And these are all the points connected. What do you see that's kind of different? Like, what's different about number 2 and number 6? There's a bunch of points, but they're not even what? They're not even lines. They're not connected. So, points only. So basically, not connected. Okay. All right, we're going to do this. This is going to be good, okay? 4 types of graphs. No arrows, 1 arrow, 2, or not even lines that are connected. So let's start with the no arrows. I kind of think it's easiest. So take a look, get one of your highlighters out, and let's zoom in on number 1. First of all, is it a function? Yes or no? Does it pass the vertical line test? No, it does not. So go ahead and write the word no above it. The next thing I'm going to ask you is, okay, what's the domain? So I'm going to use yellow for my domain. You use whatever color you want, okay? So if I go back and the domain says, what are all my possible x values? I want to know how far to the left does this graph go and how far to the right does it go. So I'm going to use my highlighter, and I know it looks like it goes a little bit over 2, like maybe 2 1/10, but we're going to say it goes as far to the left as -2. How far to the right does it go? +2. All right? So what I want you to do with one of these colors is all the numbers in between -2 and +2 are fair game for your domain. Do you agree? Okay? Here's why. Because if you find a point on the line and you go, oh, it could follow it back here, it could follow it back here, it could follow it here, it could even be -1.5, it could even be a half. It could be any number in between, right? So, this is the first type of graph we're going to talk about. How far to the left, how far to the right. So look, it can go as far to the left as -2. It can go as far to the right as +2. And watch what I'm about to do. I'm going to use D for domain. So do you agree that my domain, even on the graph and on my domain answer, is physically in between these two numbers? So watch, here's the most important part. Cover this -2 up on the left with your finger. Look at this one. I got to fill this in with one of those inequality signs. So find 2, and what are these numbers compared to 2? Go back to like 2, 1. These numbers are less than or equal to 2, aren't they? Right? Okay, that's the easy part. If I were to cover this up, we're not used to really having our variable on the right. Remember, I had you switch it to the other side, but here's going to be your hint. When it's in between like this, the signs need to be going the same direction. So this means, because how would you read it? If you read it from the domain is less than or equal to 2, but greater than or equal to -2. You can read backwards in math. You can't read backwards in English, right? You start from the right and you move to the left. You can read it. Domain is greater than -2. So I want you to look at that. Does that make sense to you that it's in between those two numbers? Agreed? Okay, so let's do the same thing for number 4 right now. Get your yellow highlighter. How far to the left can this go? And this brings up a good point. It can go as far to -3, but it can't include -3. How do we know? Because of that big old open circle. How far to the right can it go? All the way to 3, right? So, do you see what I mean when no arrows happen? It has a definite ending to the right and a definite ending to the left. So, here's what you're going to do. It can go as far to the left as -3, as far to the right as +3. Your domain falls in between those numbers, which means it has to be, watch, less than or equal to +3 because it's colored in. What symbol should I put here, though? Just a less than symbol, because the domain is greater than -3, or -3 is less than the domain. Got it? Okay? So I want you to take a quick look at number 7. All right? See if you can take a look at number 7. It should look pretty familiar. So the domain is how far left, how far right. And the most important part about writing your domain is that when you write it combined like this, it has to be where they are in relation to each other on a number line. So don't put the positive 3 here and the negative 3 there, because that's not where they are on a number line. The negative 3 is to the left of positive 3. Okay? Oops. Oh, that's mine. I had an alarm set. All right. So now put the domain in the middle. Cover this up. Look at 3. Where are these numbers compared to positive 3? To the left, which is less than or equal to. And then this one goes the same way because it's greater than negative 3. Okay. Does that make sense? All right. We've done 1 of 4. We have just covered when there are no arrows, right? So when there are no arrows, it means it's got to stop on both points on either end, and it's going to be everything in between. So let's move on to ones that have 1 arrow. So let's take a look at number 3. 1 arrow means if I go with how far to the left, how far to the right, how far to the left can this go? Forever and ever to negative infinity. So I'm not going to have a stopping point. There's not going to be any in-between business. How far to the right can it go? All the way up to, but not including 4. So watch what this is going to look like. Keep going. Right, guess what? All I got to do is figure out how to write that now. We know how to write that. We did it on test 2 or whatever that was. This is all numbers that are what? Compared to 4. To the left of 4 means less than 4. That's it. That's all your domain is. When there is 1 arrow, hey, here's a cool thing. When there's 1 arrow, there's only 1. I know that's not an arrow, but it means it doesn't have to stop at the left. It stops at the right, but not at the left. Does that domain make sense? Okay? As long as it's less than 4, you're good. Let's take a look at number 5. How far to the left can this go? And this is kind of tricky because you see that and it makes you think what? Oh, it's got to stop at negative 4. But what about that? What's that mean? It means arrow. It means keep going and going and going. Can I go past negative 4 because of that? Yep. So it's not ever going to stop at the left, but is it going to stop at the right? Yes. So this is another example of as long as it's less than that number, it's okay. So how would I write that? My domain in this case needs to be what?
5.
Yep, it can be 5. It can also be 5, so it's less than or equal to 5. You good so far? Okay. 9 is a little tricky. Let's move to 9. And 9 has an arrow. How far to the left can it go? Looks like negative 2.5, right? Okay. Now, this looks like it's kind of just going straight up. So let's assume for a minute that it just goes straight up and never veers. Even if it slants a little bit, there's going to be a difference. So let's just assume it's going straight up. Assuming it's going straight up, what would the domain be? It would be any number as far to the left as negative 2.5 and as far to the right as what? 3. And then your domain is going to be in between those, right? So it's going to be less than or equal to 3, greater than or equal to negative 2.5. Okay? If, for a second, let's assume that this had a little bit of a offshoot and it wasn't going straight up. How does that change your domain? Alex? Absolutely. Perfect. Did everybody hear what he said? He said, well, it still can't go any farther to the left than negative 2.5, but now there is no limit. Keep going to positive infinity. He said that would change it to greater than or equal to negative 2.5. Do you understand that? That's the difference between no arrows. I mean, I guess you can't really say no arrows because that had an arrow is just going straight up. Okay, are we good so far on that? So when there's 2 ending points, it's going to have a definite left end and a definite right end. When there's 1, it's only going to go forever in one direction. And now let's talk about 2 arrows. Whenever you see 2 arrows, Normally, you do a little happy dance because those are the easiest ones. Let's look at number 8. How far to the left can this go? Forever and ever to negative infinity. How far to the right can it go? Forever and ever to positive infinity. So what's my domain? Everything. How do we say everything? All numbers. All real numbers. You could say negative or positive infinity. There's a lot of ways to say it. But basically, every single x value that exists, all the way to negative 1,000, can be an ordered pair on this line because this is never, ever, ever going to stop. Do you understand that? Okay? So that's that one. The only one we have not talked about or done is 2 and 6. And what do you notice about 2 and 6? They're not even connected. They are just plotted points. These are really quite easy too. So if I were to name the points, I would name them -4, -4. The name of this one is 1, -2. The name of this one is 3, 3. And the name of this one is -3, 4. And so then I would just go back and say, hey, what are all my x values? -3, +3, +1, -4. And then I would list them in order. I would say -4, -3, +1, +3. Do you want an even easier way? Yeah, I know you do. You don't have to list the ordered pairs. All you have to do is follow these up to where they hit the x-axis at, right? Do you see it? So do you see it hitting -4 and -3 and +1 and +3? So you don't have to waste your time listing the ordered pairs because if you did, they would be that. So go ahead and try for number 6 to find the domain. You have -3, 0, 1, +3? Yep. Okay. Ready for a summary. So here's the summary. You have 4 different possible answers for your domain. If there are no arrows, it's going to have a definite left end and a definite right end. And that's when it's going to look like this. Okay? So I'm just kind of showing you what it's going to look like when there are no arrows. Because it can only go as far to the left as a certain point and as far to the right as a certain point, and it's done. Okay, when there's one arrow, it's going to look like this. Like it could be greater than or equal to 4, or your domain could be less than 2.5 or whatever. It's only going to look like one endpoint. If it's got 2 arrows, usually it'll be what for your domain? All real numbers. Okay? I say usually because I'm going to show you number 5. Number 5 is kind of a weird, wacky graph that we're probably never going to see in Algebra 1 other than for this lesson right here. How would that change? What if that was an arrow? Does 2 arrows mean all real numbers every single time? No. Because if this was an arrow and this kept going, my domain would still be less than or equal to 5, wouldn't it? Because both of these arrows are going in the same direction. So that's why I say most of the time. You're not going to see one like that too often, though. Okay? And then when the points are plotted and they're not even connected, that's when you're going to see a list of numbers. So your domain would actually be like 3, 0, 1, 8. All right. So this is kind of your guideline. No arrows, ending. Goes forever in one direction but not the other. Everything, and then only certain points. Okay, so here's what's really cool about the fact that I took a lot of time to explain that. Because I still have to go over range with you. Except what? It's the exact same rules, except I'm not looking at how far and how to the left and right. Range is the y-axis, how high, how low.
So you
So-
just like flip the paper 90 degrees.
You could, but actually, if you think about it, like how low can you go, that could be the statement for that. Get your other highlighter out. I'm going to get a clean piece of paper out because we're doing the same thing. We don't really need to flip. I'm just going to do it this way now. How high up can this go? It can go as high as... Now, this is what you got to be careful. Okay, be very careful. Because normally when you go to write your range, you write the top number first, but is positive 2 to the left of negative 2 on a number line? So be careful. I'm comparing 2 and negative 2. So negative 2 is to the left of positive 2. My R for range now is cover this up. Look, look, look. I'm covering that up because I like it when the variable's on the left. I'm looking at positive 2. I'm looking at positive 2. Where are the numbers highlighted? What sign goes in there? These numbers in blue are what compared to 2? Yes. And once I have that sign, I know that the other one has to go that way to show that they're in between. Yes? Okay. Go to number 4. This one's a little tricky. How high can it go? It can go as high as what? 2. Can it be 2? Yes. This is not colored in, but it's covered on this one. How low can this go? Is all the way down to negative 4. Be careful when you write your numbers. What number do I want to put on the left? Negative 4. How far up can it go? 2. Range. Watch me. Cover this up. Look at 2. Look at 2 here. These numbers are what compared to 2? And so this has got to be greater than or equal to negative 4. Try number 7 right now for range. How high can it go? Up to 3. How low can it go? Down to negative 2. So put negative 2 on the left because that's where it's at on number line. And then compared to 3, here it's all less than or equal to it or greater than or equal to negative 2. Are we good on those? Okay, let's look at number 3. I got one arrow. All right. Actually, this one doesn't really, this is more of like the first 3, right? Because how high does this go? How low does it go? So even though there's an arrow, that's really taking care of the domain. If this had a little bit of a twist to it, that would change the range, wouldn't it? Let's do it without it. Let's do it as is. It can go as high up to 4 but can't be 4. It can go as low down to negative 2. Cover this up. Compared to 4, where are all these numbers compared to 4? They are what? Just less than 4. Not less than or equal to, which means this one goes here. Do you see why I put a line under it? Here, but not here? Because it goes right to 2. How would that change my range if this had a little bit of a tilt to it? Then there would be no stopping. It could keep going and going and going and going, and that would mean my range would be what? No, because then because it can't, it has a stopping point at the top too. It would have to be what? Any number less than 4. Does that make sense? That's if it had that little tilt to it. Okay, let's take a look at number 5. How high can it go? We're just going to say 3 for the sake of argument here. How low can it go? To negative infinity. So, as long as my number for my range is what compared to 3? Less than or equal to 3, we're good. Take a look at number 9. How high can it go? Positive infinity. How low can it go? Are you getting this? It's not too bad. As long as my range is greater than or equal to -4, that's fair game. Are you with me? Take a look at number 8. How high can it go? Forever and ever. How low? Forever and ever. Oh, that must mean my range is all numbers. Try number 2 and number 6. You with me? Does this make sense? Okay. How high, how low, how far left, how far right?